Hi, I'm Guo Cheng Guang, secondary 1 from NS High School. In this lesson, in this part here that we're going to have will be electromagnetic dynamics. For this part of electromagnetic dynamics, we're having the calculations of electrostatic force or electrostatic field strength for these parts. And in fact, for now, we're having between a uniform charged rod or a uniformly charged rod and a point charge. So from this it is shown below here, or you can also refer to this part that we're going to have. So in order to solve these kinds of questions, first of all, when you look at this, it means that we're going to solve for E. Okay? So since we're going to solve for E in this part, the frontmost part, the R pi epsilon naught, it is always this constant here. After that will be Q. So since this is E, you only have one charge, and then it will over R square. So it is the square of this length that you're going to have, or the square of the distance from the source charge that you take to the test charge here, or it's the distance between two of the points there. So then after that, we're just going to use our unit vector to show the direction, but for this R unit vector, it starts from the source charge that you have taken, and this unit vector points towards this point P that you have here. So for this part, it will be for our electron. So it is this one first. Then after that, this constant part, no problem first. Q, since in our rod here, Q is the entire thing, that means we're going to use dQ for one small part. Then after that is our R. So for our R, means it is a distance, like if we take this part over here as an example, then it will be this distance that you have. So this is the part that you're going to have for your R. And for this part, when we're finding R, we're just going to let this part be X and here be Y. So that means to find R, you use the Pythagoras theorem and you get square root X squared plus Y squared. So this will be for your R. Then after that, we're going to use DE. So for DE in this part, so in the first part it is still 1 over 4 pi epsilon naught. Therefore your charge that we're going to have is still dQ. So the square of distance here will be x squared plus y squared. But then for this part, if we just want to find dE, if we only want to find this, since it goes in this direction, and it is not directly in the x direction or directly in the y direction, so you'll have two components for this part. So let's just say for this part it is dE. So that means the part that you have here, so it's actually this part will be dEx. And then after that, for this part will be dy. So that's the part that you have. So you have separated it into two of its components, and we can choose to have either one of it first. So let's just say we find for the x component first. So x component for this part, that means we need an angle. So what if we just let this angle be theta? So if this angle here is theta, that means here will be theta. So just by using adjacent and hypotenuse that you have, you will need to use the cosine. So that means you have to times cosine theta. Then this is equal to, the constant remains the same. Oh, in this part, there's one part that will be changing, or actually two parts. First of all is the dq. So dq, which is one small charge in this part, I'm going to split it out into q over L. So q over L, you can say it as this linear density. So q over L. Then that means for this part, we're just going to let one small of this part be. So here, one small of this part will be dy. So up here, we'll be using dy. Then you have x squared plus y squared. So cosine we could actually also change it just by using, since theta are the same for both of these, then we could use this theta to find for cosine theta, which will be x over square root of this whole thing. Alright, so this is the part that we're going to have. So here is dex. So dex. How about actual ex? So all the constants we can take it outside. Okay, so you have qx over 4 pi epsilon naught L. So then you'll be, you start to integrate, then this part will be dy over x squared plus y squared, the power of 3 over 2. So y in this part, according to here, will be from 0 to L. Okay, so that's what you have. So then afterwards for this part, you look at the denominator, you realize that you have y squared. And for y squared, we can't solve it directly. So that means we have to make a little bit of change. And we can use let y be equal to. So according to this part, what you will need will be tangent theta. If we let it be theta, what if it is the same? Wait, then they're actually correct. Since y is the opposite, x is adjacent, so that means this part is actually correct. So since this part here is actually correct, that means we could use dy equals, so x here, well, it will just act as a constant. So x, then tangent theta will be secant square theta d theta. So at this point I'm going to have dy being equal to this part. And then since the range for y is 0 all the way to L, that means theta, what we need will be, so when it is 0, that means the whole thing is 0, and we need 0. Well, to what? we put it back inside here. L, that means here when you times L over X. So L over X, then put inside, well, we're just going to write inverse tangent L over X. Since this X here is not fixed, and L will also not given, we're only given that it is L. So then we put it inside here. They have Qx over 4 pi epsilon naught L, and this part just a constant that stays the same. Then you can integrate from, so currently this theta 0 to inverse tangent L over X. Then dy for this part, dy will change it to here, x secant square theta d theta, and then over. So from here, x square plus x square tangent square. So both of them have x square, so take them out. What you actually get will be x cubed. Then 1 plus tangent square will be a secant square. So you get a secant cube. Alright. So then it will be equal to qx over 4 pi epsilon naught L. So when you simplify, you actually get 1 over x squared. So 1 over x squared is just that constant. So yes, we can take it out. Then after that, we'll be left with 1 over secant. And 1 over secant is actually a cosine. And cosine, it will come from sine. So that means you could just put it as sine theta. Well, for sine theta, that means it is opposite over hypotenuse. Okay. Wait, so this part we can actually simplify. Alright. So from this part, firstly, it will be opposite will be L over. So it is over the hypotenuse, which will be x squared plus L squared. So this is, wait, one more. The hypotenuse, Pythagoras theorem, you have that square root. Alright, so this one part. Well, that means you have Q over 4 pi epsilon naught x square root x squared plus L squared. So this is the part that I'm going to have for e to the power of, ex. Another part will be d ey. Well, for ey that you find over here will be in the opposite direction from the actual y. So that means it goes down. So that means you have negative first. Then after this negative that you have 1 over 4 pi epsilon naught. Well, this constant is definitely there. dq, this is still the same for the charge that you're going to have. Then you have, okay, so this part is dq over, well, still x squared plus y squared. But then if you refer to one of the parts over here, so actually if you connect this part together, it'll be dey. So you'll need the opposite and the hypotenuse, which you're using sine. Okay, so in this part we have sine theta. Afterwards, we're going to make a few same changes. First of all, dq, yes, same kind of change. So you have q, then dy over L x squared plus y squared. Afterwards, sine for this part opposite y over hypotenuse square root x squared plus y squared. Then afterwards, so you do have this part already. So you can sort of combine them together. But don't forget the negative. You have q over 4 pi epsilon naught L. Okay, so I think this is so far what we'll have. Then afterwards, y dy over x squared plus y squared, but this power will be 3 over 2. So this is part that you're having. Then you can find EY. So when you're finding EY constants, you're still making it stay outside. Alright, so in this case, negative q over. So from here, what we're going to have will be okay, wait. So from the first integration, we have from 0 to L. So in the second integration, also need to have the boundary. So the boundary in this case will, according to that y there, it is still 0 to L. So this part is always left in the integration here, or at least in this case here. Then afterwards, y, we can choose to put it inside. So that means we'll need extra half. So you get over 8, then pi, then epsilon naught, then L. So you still get 0 to L, but inside here will become dy squared, then over x squared plus y squared, then to the power of 3 over 2. So from this part, you can actually realize y squared, they are pretty much the same already. So you can just look at it as a z possible, or then just take this x squared in front as a constant, so you can just add it on. And then this power is negative 3 over 2, that means you need negative, so 3 over 2, that means it came from 1 over 2. So 1 over 2 so then after that, wait, I'm just going to write this in fraction form. So from here, firstly, you sub in an L. That means it is square root x squared plus L squared. Then you subtract. So you sub the 0 inside. Then you have x. It's 1 over x for this part. Then afterwards, for this part, x, then you subtract square root x squared plus L squared. So this is the final form that we're changing it into. But when some of you look at this form, you may wonder, like, at first we started with a negative, how did we end up with something like positive? But actually still a negative if you're very careful about it. Since this part x, but this part square root x squared plus L squared, if it's only square x squared, is x. But since you have added L squared under the square root, that means at least you have increased by a bit, or even it may be a lot. So this part, it increased it. That means this square root is larger than the x, and that means this part is actually a negative, and that's how you still have that negative. Well, it may seem like it's very long already, but wait, we still have another part. We have only found ex and ey. Well, what do we need to find at last? The last thing that we need to find is the e. So we need to find e at last. So e for this part will be, so ex squared, then you add ey squared. Wait, is this the same? No. You need to square root the whole thing. So then, what you get? So just not to make it much more harder, we can first of all factorize parts that are already the same. Like q is the same, 4 pi epsilon naught, x and this square thing is the same. Okay, so that means we're going to take all of these parts out first. And then after that, here you have an extra L at the bottom. Well, you could also choose to take that out here. Just that this part you change it into L squared. So L squared, then you plus. So Q, okay, not that part anymore. It is here. X subtract square root x squared plus L squared. Then square. So if you still want to continue to like simplify or just expand, you can still continue, well, just at the last form. I guess I'm just going to show that for the last part. So x squared, but when I expand negative to square root this, then add another of this. So then you get 2x squared, then subtract 2 square root x squared plus L squared. Then you will add 2L squared. So this is a final form that you can put it as for this part. Alright, so this, let me see again. Wait, yes. Here, well, after you expand it, negative 2ab, so that means you have negative, so minus 2x, then square root. Okay, so this is the first part that we're going to have. Whereas you're going to find for each of them ex, then ey, then the whole e. So this whole e will be this part here. Alright, so this lesson, I'm just going to end here. So, if you like our videos, don't forget to subscribe to our channel. We will see you in the next lesson. Thank you for your watching.